Hello everyone, welcome back to another AP Physics 1 daily problem. Today we have a kinematics problem that we'll go through from the MIT AP Physics 1 workbook that will be in the description down below for you guys to go ahead and walk through with us as well. With that being said, let's go ahead and read the question. It says the graph above shows velocity versus time for an object in linear motion. Which of the following is a possible graph of position x versus time for this object? So when I get these type of problems, the first thing I like to do is just cross out the answer choices. For me, this helps me to not choose a choice that I'm just naturally, just automatically attracted to and choosing the wrong one. And because of that, it says which one of these could be based off the graph of here. With that knowledge, we have to go ahead and first decipher what this graph is telling us. So remember guys, a velocity versus time graph is the slope of a position versus time graph. And velocity is a vector. And a vector means that it has both magnitude and direction. And since it has both magnitude and direction, that means when we see a negative value, it means more than just a negative value. So with that being said, we'll go more in depth in that. So looking at it, we can see, let's split this up into three different sections. We can make one line here, one line there, and then one line there. So if we look at this first portion right here, we can see that it has a straight positive line. And if it has a straight positive line with a slope of 0, that means it's constant. It's not changing. And if something is constant and not changing, that means it's going to stay the same value. And if something is traveling with the same velocity, that means it's going to have a linear position versus time graph because it's going to continue covering the same distance in the same amount of time because it has the same velocity. So if we make our own position versus time, or x versus time graph, we could see at the beginning we'll have, here let me break it up like this. At the beginning we'll just have a positive slope increasing like this, and this will be our 0. um, Let me go ahead and make this better positive here. Next we have this middle section. This middle section has a downwards line that passes through 0 and goes negative. And what this tells me is that our velocity went from that constant positive value to decreasing and becoming negative. And what I know is that at one point it was 0. And if an object has a velocity of 0, that means it was still. And if it was just for momentarily or even like a second, that means I know that at some point my position versus graph is going to have a flat line at the top. So we can go ahead and just draw a flat line at the top because we know it crosses 0. And just because the slope is going down negative, that doesn't mean we're automatically traveling negatively. That means that we are slowing down. So if we're slowing down, that means our position versus time graph slope is going to decrease. That means we're going to be covering little and little distance as time goes on. So our graph is going to curve a little, meaning that it is going to curve downwards towards that 0 line. So if it were me, I would just draw this little curve up to, it's a curve down to the 0 line. And here we can see after we have this little portion that is negative now. And that negative portion means we're traveling in the opposite direction. Because remember, velocity is a vector. And a vector means it has both magnitude and direction. So that negative is telling us that it's actually in the negative direction, which means it's in the opposite direction we came. And the opposite direction we came, if we have a straight positive line, meaning we're traveling to the right, traveling to the left would be the opposite but the same value, so it'd be a straight line downwards because we're going back the same way we came. With that knowledge, I'm going to go ahead and start drawing a downward curve because it's not constant yet. It's still very small and increasing slowly. I'm going to draw a curved down line again because it's going to negative direction. But this time I'm going to draw getting a little more straight. Now, with that being said, we have our last portion right here. Here you can say that it's pretty much constant, and it's constant negative. So seeing that this portion right here and this portion right here are kind of alike, I'm going to assume that my graph is going to have a similar image of those two portions. But in this case, it's in the negative right here, the negative portion. Knowing that's in the negative portion, that means it's traveling in the opposite direction we came. And as I said earlier, if my graph is going positive upwards, meaning I'm going to the right, increasing, if I'm going the opposite direction, I'm going to draw the same slope, but downwards, because negative, here's a positive slope meaning we're increasing our distance traveled, and then we have a negative slope meaning we're decreasing our distance traveled, because we're going the way we came, and then that's our positive, and then we're going to in a different color, we're going to come back the way we came, being negative. And with that being said, that would finish our graph off with just a downward sloping line like this. Now that I have my position versus time graph that could represent this object, I can go ahead and now find which graph matches this up. Looking at our answer choices, I see that choice A is a pretty exact replica of what I wrote. So me personally, I would go ahead and select choice A, but let's go select choice B, C, and D and see why they're wrong. Choice B shows us that the position stays the same at the beginning, which is already a red flag, because we said a constant positive velocity means we're going to be having a positive constant slope, increasing going over. So just automatically looking at that, we can say that's incorrect. Choice C has it doing some parabolic downwards up. We can already tell that's incorrect because we have, as I said, a constant slope. Constant slope because we have a constant velocity, meaning we should see some straight line at least here. But that is not a straight line, meaning choice C is incorrect. Choice D is straight line here, straight line down, straight line here. But the only difference is instead of traveling downwards, because just because our velocity is negative, like I said, just because it's negative doesn't mean our position is negative. The velocity being negative means we're traveling in the opposite direction we came, meaning we have to come back the way. So dropping all the way down to zero position doesn't make sense. In traveling in the negative direction, going even further back the way we came, because this is our zero position, going even further back does not make sense at all. So that means choice D is incorrect, leading us to choice A being our correct answer. I hope you guys enjoyed the video. If there's anything you didn't understand or was unclear, please comment down below, and I'd love to go and answer your questions and make any videos you guys want me to do. I hope you guys have a good day. Please continue your prepping, and remember to enjoy life.